So, our today's topic is the Kruskal algorithm. In the last lecture, we talked about the minimum spanning tree, what is a spanning tree, and the Prim's algorithm for computing the minimum spanning tree of a given graph. So, today we are going to talk about the Kruskal algorithm for the same purpose, computing the minimum spanning tree of a given graph. So, according to Kruskal algorithms, we basically, if you talk about the basic idea, then we simply create a forest of trees from the vertices. And the basic difference between Prim's algorithm and Kruskal algorithm is in Prim's algorithm, we works on the vertices, that is, on the nodes. And in Kruskal algorithm, we work on edges directly. And the both have same result. Then suppose in the last example, we computed minimum spanning tree by using Prim's algorithm. So I am taking same example to compute minimum spanning tree by Kruskal algorithm, and we will see that we will find the minimum spanning tree of same cost. So what we will do, we will create a forest of trees from the vertices, and for that repeatedly we merge all these trees by adding safe edges until only one tree remains. It means when all the vertices will be in one set, that is, they are forming a minimum spanning tree. So safe edges means here safe edges means whatever edges we are selecting, it will lead to a minimum spanning tree. So a safe edge is an edge of minimum weight which doesn't create a cycle, and hence we say it is a safe edge. Okay. So suppose take this graph. We have five nodes here: A, B, C, D, E. So the very first step will be simply a forest, that is of A, B, C, D, and E. You can see here. Okay. Now we will talk about the detailed algorithm of the Kruskals. Firstly, we will initialize, and in initialization, we will create a set for each vertex. So basically, these set will denote that forest. So suppose we have a five vertex in this graph. So there will be five set corresponding to each vertex. So you can see here we have set A, B, C, D, and E. So it is just an example. Now initialize the set of safe edges capital A comprising the MST in beginning as a empty. So this set A will consist of all the edges which will create a minimum spanning tree of that graph. Third step, sort edges by increasing weight. So in this graphs, we have sorted. You can see that we have AD. You can see this AD minimum weight, that is 2. Next we have 4. So this CD and DE. We can write here DE or ED because it is undirected graph, so both are equivalent. So in this way, we will sort all these edges according to their weight. So you can see AB having largest weight is on the last point. So this is the initialization part. We will create the vertices of set for each vertex, and we will set take a empty set A, which will consist of safe edges comprising the MST, and the third one we will sort the edges according to their weight. Now this is the main step of Kruskal for computing the MST. So what we will do, as I said, we will work on edges in the Kruskal algorithm. So for each edge in the edge set, in increasing order, we have already sorted the edges according to their weight. So in increasing order, we will select each edge while more than one set remains. So for each edge, if both end of that edge, that is U and V, belongs to different set, say capital U and capital V, then we will add that is UB to safe edge set capital A. That means now it will be in our MST, and then we will merge these two set capital U and capital V. So merge the sets capital U and capital V. So that is, you can say F is equal to F minus U and minus V. That is, U and B will not exist now, and we will add a new set, that is U union V. And whenever we will get a single set, then this loop will be terminated, and whatever the edges we have in this edge set capital A will form a minimum spanning tree. So it is the basic idea of Kruskal algorithm. Now, regarding the running time, so by sorting for find minimum, the minimum spanning tree, we will have the time complexity with E log E, yeah, equivalently E log V, because we are working on the edges. Now take this example. This is the same graph we have taken for Prim's algorithm. So this is the edge set we have sorted in initial stage A, and these are the set corresponding to each vertex A, B, C, D, E. And this is the set A of safe phase. Initially it is empty. So this is the initialization step. हमने already बात कर लिया है हुआ है इस पे. Now, if we apply second step, then take this first edge AD. This A belongs to this set and D belongs to this set. So both are in different set. Say it is capital U and it is capital V. So we will add this edge AD to this safe edge set capital A. So now this AD is in this capital set A, and we will merge this both set A and D. So now this is the result of first iteration of the loop. So now we have worked on this edge. Next one we have CD. You can see C is here in this set and D is here in this set. So again, both are in different set. Then CD will be included in this A, and we will again merge AD and C, and we will get this one. Now next one, DE. So DE, D is here and E is here. Both are in different set. Then again D will be included in this set A, and we will merge a this set and this set. Next one, AC. You can see this AC both are in same set. So that's why this AC will not be included in our MST set A. Next one, BE. B is here, E is in this set. So both are in different set. So that's why B will be included in our MST, and both will set will be merged, and we will get this set. Now, if you remember, this loop will be executing only when we will have condition that while more than one set remains. Now you can see we have just one set. So our loop will be terminated. So whatever the ages we have in this set A will form our minimum spanning tree. So you can see this AD, then CD, DE, and BE. So you can compute the total cost 2, 4, 4, and 5, that is 15. So we had same cost and by Prim's algorithm, and we got same minimum spanning tree. But it may be that if you found the MST by Krushkal algorithm and by Prim's algorithm, maybe we get different MST, but the total cost of the ages involved in the MST, the total cost will be same. So this is all about Kruskal algorithm. So in the next lecture, we will discuss about the shortest path algorithms. So enough for today. Thank you.